So we are starting loudspeaker. It's a part of electromagnetism. Loudspeaker is a part of electromagnetism. Loudspeaker is a part of electromagnetism. I just put my first concept here. Introduction, it's a device used to increase amplitude or intensity of a sound signal. Loudspeakers are common in our mobile phones, in our other devices. Loudspeakers are very common in our devices, and it is in all sound systems. Basically, normally our sound is not that much high. So we use a loudspeaker to increase the amplitude of the signal. Loudspeaker works on the principle of electromagnetism. What is electromagnetism? When current produces magnetism, it is called electromagnetism. When current produces magnetism, it is called electromagnetism. You have to copy this screen.
Done.
Good. When current passes through a conductor and it produces a magnetic effect, it is called electromagnetism. So electromagnetism is actually phenomena of electric current.
Done.
Now, a loudspeaker, what's the plan of a loudspeaker? A loudspeaker actually does not increase the amplitude of our input sound. It appears to be so, but actually what happens that loudspeaker receives our sound through a microphone and it copy our sound. It actually imitate our sound. This is called imitation, and then it uses a signal method to amplify the signal. It uses AC and
Is it not like
electromagnetism.
echo then?
Sorry, I have.
Is it not like echo then?
Sorry, are you? No, I didn't answer. What did you say?
I'm asking, is it not like echo then? If it's
No. It is not like echo. Echo means sound strikes a surface and come back. This is called echo. So it is not a case of echo. It's a case that you listen to someone. You must have seen those stage actors, the comedians, etc., who imitate the sound. So you listen someone's sound and you copy it. So actually, The loudspeaker is a copier. It regenerates a sound and it uses AC and electromagnetism to generate the sound. When it generates the sound, it amplifies it. This is a core concept to understand. You have to copy this screen.
Done.
Now, what is a sound signal? A sound signal actually is is a signal of longitudinal waves. Sound waves are technically longitudinal waves. The identity of a signal is always frequency. So when you listen to someone, if you hear the sound of your friend, how you identify the signal so quickly, it is the frequency. Sound signals are actually longitudinal waves, and it's a series of compression and rarefaction. So sound signals are like this: compression, rarefaction, compression, rarefaction. This is how sound signal proceeds. A sound wave is like this. It's a signal in which the amplitude gives the intensity. So what's our main target? When we measure the height of a wave, it is called amplitude. When you go to a seashore for a picnic or for outing, you see that the high tides, high waves are able to transfer more energy. So wave height, amplitude, intensity, and this is called loudness. So when you increase the loudness of a signal, when you increase the loudness of a signal, you actually increases the amplitude of the signal. I repeat the concept. When a loudspeaker or when you even speak loudly, you do not change your frequency. You actually change the amplitude. Now you have to write down, give a side heading sketch. Loudness increases the amplitude.
Done. Done.
Now, what is the origin of sound? Remember this concept that sound is produced by the vibration of a source. Look, this is how sound is produced. Sound is produced by vibration. So the people who are working, the people who were working on this concept of loudspeaker, they first thought how to generate the sound. Sound is produced by vibration. So now give the heading, side heading, origin of sound.
Done.
Then write under it that sound is produced by the vibration of a source. Sound is produced by the vibration of a source.
Done.
Now, give a side heading, working. Give a side heading, working. Now, look at this diagram. This is the internal structure of a loudspeaker. It has a cylindrical magnet. It has a cylindrical permanent magnet, and there is an AC supply. So this is an electromagnet. When you switch on the electromagnet, North Pole and South Pole appears. The North Pole and South Pole appears on the electromagnet. Look at this position. This is a South Pole and this is the South Pole. Like poles always repel each other. So this paper cone, the cardboard cone, moves outward. Later what happens that AC, this is an alternating current. AC reverses its polarity. Now there is a North Pole in front of the South Pole. So there will be an attraction. Now the cardboard cone moves inward. What is the result? This is an electromagnet and we have a permanent magnet. Look at this diagram and this motion carefully. This is what happened inside a loudspeaker. The paper cone in this way vibrate. The paper cone vibrates. Look at this vibration. The paper cone vibrates. This vibration is able to produce sound signal. Sound signals are produced due to the vibration of. Look at this small animation. This is a paper cone and the paper cone is vibrating. Okay, this is a very nice animation to understand. Look at carefully that a loudspeaker has a paper cone which is vibrating. So this gives the concept that a paper cone vibrates due to the motion of a paper cone vibrates. Look at this circular electromagnet. So it's a combination of, it is a combination of two magnets. Now you had given the heading working. So after giving the heading working, copy this screen.
Done.
This is how this apparatus works. Now, this is the apparatus working. Now, when the electromagnet is energized by alternating current, this produces alternating magnetism force between just keep on copying with me, force between permanent and electromagnet reverses. Paper cone vibrates. This is a mechanism to how we produce the sound. You have to copy this screen.
Done. Done.
This is called electromagnetic effect. Now, the point comes here that how we are going to increase the amplitude. That is to say, the concept of amplification. Now, copy this heading, amplification. Amplification.
Done.
We want to increase the amplitude of some more electrical energy input, more intensity, more amplitude, and louder signal. Plus, the paper cone has a bigger size. We increase the energy input, and we also have a wider surface area of the paper cone. Look at this paper cone, it has a wider surface area, due to which it can increase the signal loudness. You have to copy this screen.
Done.
So right under it that now make the concept, a loudspeaker does not change the frequency. That is why the sound is loud. The sound is loud, but the accent is the same. It won't be a new person's sound. It will be the sound of the same person. The input is AC. The frequency of AC is the frequency of the sound. So electromagnet, paper cone vibrate. So what happens? The paper cone vibrates on the frequency of the input current. So suppose you are having a microphone, you are talking on a frequency of 20 hertz. So 20 hertz will be given to the electromagnet and the paper cone vibrates on the same frequency. So a loudspeaker does not change, frequency. You have to copy this screen.
Done. Done.
Now you have to copy this.
Done.
Now, this is the top view. Top view is another big problem in our camera system because it's a visualization issue. Dot means out of the page and cross means in the page. So just imagine that the loudspeaker is on a table and we are looking it from the top. So here the dot means out of page and cross means in the page. This is the top view. So now you have to copy this screen.
Done.
This is the conventional loudspeaker. Now they are rare. Now we are using electronic systems, but this is a conventional loudspeaker in the high stereo system, in the loud systems. It's there. This is the appearance. This was the appearance of the conventional loudspeakers. Now we make a summary that how it works. You have to now copy this. This topic is ending. You have to copy this screen. And I'm just coming. Copy this screen. Let me know once you have copied it.
Yes, I've done it.